All right, guys. So we are looking at section 6.6, part 2. So we're going to be looking at how to solve exponential and logarithmic inequalities. So not equations, but inequalities. The first case, if you have an exponential inequality, we're going to take the log using the same base as the exponent's base of both sides, and we're going to solve it. Case 2, if we have a log inequality, we're going to exponentiate both sides using the appropriate base. If we have a logarithm, we must look for domain restrictions, okay? But only if we have a log. If we start with an exponential inequality, we don't have to worry about it. There are no restrictions because the domain of exponentials is all real numbers. Here's a common thing that happens. If we see log base b of b to the x, that's x. If we see b to the log base b of x, that's x. All right, we're going to solve these inequalities and we'll check on our graphing calculator. All right, so number 12, we have log x is less than or equal to 1/2. So how do I get rid of a log? What's the opposite operation? Okay, so I have to exponentiate. What's the base of this log? So I'm going to have to do 10 raised to the log, and I know the base is 10 there, of x is less than or equal to whatever I did here. I exponentiated with the base 10, so I have to exponentiate with the base 10. What is 10 log base 10 of x? Is it x or is it 1? X. So x must be less than or equal to 10 to the 1/2 means the square root of 10. Now, I have to check the domain here, though. What must be true of x if I have y equals log x? What's the domain of that? X must be what? Greater than 0. X must be greater than 0. So let's make sure we have that. Well, if x is less than radical 10, is x always going to be greater than 0? No, not if it's less than the square root of 10. Square root of 10 is about, what, 3 point something? So we're saying x is less than that. So we're also going to have to say that x has to be greater than 0. I want you to look at the original problem on the calculator. Into y sub 1, we're going to put in y equals log x. Into y sub 2, we're going to put in 1/2. I'm going to do a zoom 6. Here's the way it looks. We're being asked, where is it that the graph of log x is less than or equal to 1/2? Well, it's the graph log x doesn't even start until we're a little bit above 0. If I hit trace, see how the first time I get an answer for that is when x is 0.15, a little bit greater than 0. Let's now find that intersection point right there. Second, trace, calculate, intersect, get over there kind of close to it, enter, 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 and I get 3.162. What do you think that is the same as? Square root of 10. Remember that number. Square root of 10. 3.162. Okay? So that's what we're saying here. We have to check the domain, and then we have to check and make sure that that answer was right and both are correct. So if we have a less than with a log, we're going to have to check for that domain restriction. Yeah.
Can you explain what the restriction part, like why it's greater than 0?
Okay, all you have to do is look at the argument on the log, and you have to say that always has to be greater than 0. So if it's x, x has to be greater than 0. If it's x plus 1, x would have to be greater than -1. If it's x minus 3, x would have to be greater than 3. Okay? Questions on that? All right, let's look at number 13. Anytime we're dealing with an exponential or a log, we have to get it as isolated as possible. So what am I going to have to do first? Subtract the 1. I still need to have that base by itself. So what am I going to do? So we're going to have e to the x must be less than 3. Now we're ready to do This is an exponential, so what's the opposite of an exponential? A log. So what base am I going to use? E. Okay, so if I want to use a base of E, I'm going to use natural log because that automatically means I have a base of E. So I do this. So how does this simplify? What is natural log of e to the x the same as? Just x. That's because exponents become coefficients and natural log of e is 1. So this is x must be less than natural log of 3. Now, do I have to worry about restrictions? No, because what type do I have at the beginning? Exponential. Their domains are all real numbers. So I do not have to worry about any restrictions. That is my answer. All right. A log. Will I have to think about restrictions? In fact, what will x have to be greater than? -1. Good. So now I have to isolate my log. So I'm going to divide by -4. I have log base 3 of x plus 1. If I divide by a negative, what happens to the inequality? Flips. So this is going to have to be less than 2. Now, how do I undo a log base? What's the opposite? Exponentiate. So it's 3 to the log base 3 of x plus 1 has to be less than 3 squared. Okay, look up here. B to the log base b of x is x. We have b to the log base b of x plus 1. So what is it? X plus 1. So x plus 1 must be less than 9. So x must be less than 8. But what else has to be true for x? It also has to be, is it less than -1 or greater than -1? So I have to say x is greater than -1. And that's going to be our solution. Okay? Question. All right, I want to do a couple more with you. Let's take a look at number 1. We're solving this for x. We've never done a problem like this before. This is actually a trinomial. What do we do to solve a trinomial? We do factor. We set up double parentheses and we factor. We have to look at the first term and we have to think what times what would give us 3 to the 2x. So my other class said 3 squared times 3 to the x. But when we're multiplying, if our bases are alike, we add the exponents. Would 2 plus x give us 2x? So what are we going to do instead? 3 to the what? Okay, let's see if that works. If I multiply these, my base stays the same, and I add my exponents. Is that going to give us 3 to the 2x? Yes, so that's correct. Good job. Now I'm going to look here. What are numbers that multiply to be 15 and subtract to be 2? Okay, 5 and 3. So when I do my outers, I'm going to get 3 times 3 to the x. When I do my inners, I'm going to get 5 times 3 to the x. I can't multiply those. I'm trying to get a -2 times 3 to the x. How do the signs need to go? Okay, so positive on this, negative on that. All right, great. So now we have it factored. So 3 to the x minus 5 has to equal 0. And 3 to the x plus 3 has to equal 0. Well, I want to solve this now. So I'm going to add 5, and I have 3 to the x equals 5. And I'm going to subtract 3. 3 to the x has to equal -3. Do you guys know this? What's 3 to the first? 3 to the second? So our answer's somewhere between 1 and 2, right? How am I going to find it? How do I undo an exponent? Log. Log base 3 of 3 to the x equals log base 3 of 5. So what's this going to be? Just So x is going to have to equal log base 3 of 5. What about here? Well, anything to a power, or sorry, 3 to any number, give me a negative 3. What's 3 to the negative 1? What's 3 to the negative 2? Am I ever going to get a negative? No, this has no solution over here, but that's my only answer. So now let's find the approximate answer. We go under math. We're going to go up to log base. Going to do log base 3 of 5, and that answer better be between 1 and 2, and it is 1.465. I'd like you to get in the habit of giving both the exact and the approximate answer to 3 decimal places on these. Okay, makes sense? Awesome. Want to do one more. Tough problem here. Look at what happens. We have log base 2 of x equals log base 4 of 84, or sorry, of 8x. Well, the problem with this is I'd like to just say x has to equal 8x, but I can't because the bases aren't the same. Don't we have a change of base formula? Look at the board at the fourth one. It says this. If I have log base a of b, I can write that as log base c of b over log base c of a. I can choose any number I want for c. Well, I want to get the same base. So what base am I going to use on this right-hand side? 2. So I'm not changing the left. Keep it. But I am going to change this. Here's b, here's a. So what's it going to be? Log base 2 of 8x over log base of, all right, look at this now. This is great because can I just do this? What is log base 2 of 4? 2 to the what's 4? 2. So that's just 2. So now I have log base 2 of x equals log base 2 of 8x just over 2. What do I do? If this is just divided by 2, how do we undo it? Multiply by 2. Does anybody remember what I can do if I have a coefficient of a log, where I can put it instead? Yeah, because I want to get log 2, or log base 2 and log base 2. So watch, we can do log base 2 of x squared equals log base 2 of 8x. See how now we have log base 2, log base 2? So what do I do? So x squared has to equal 8x. So x squared minus 8x has to be 0. Factor out an x minus 8. So my solutions then are going to be 0 and 8. Okay, so we're taking a test and we say, yes, we're done, 0 and 8. But can the answer be 0? So I'm going to throw it out. Let's check 8. If I put an 8 in there, what's 2 to the what would give me 8? If I put an 8 in there, 8 times 8 is 64. 4 to the what would give me 64. Aren't they equal to each other then? That's our answer. X equals 8. Okay. These problems are really interesting, but it's all about using that same base on the left to make it so that it's something that you can evaluate. Rachel?
It can't be 0 because it started with the log first. That can't be greater than 0.
Correct. In fact, you might even want to write that at the beginning. Like some people just like to say, hey, whatever I get for X, it's got to be greater than 0. And some people like to check the end. So, all right, makes sense? Okay, then after lunch, we're going to do a really rigorous problem, but we're going to stop there for now. Okay.
Hi.